design to give some background to where we're coming from on this. User-centered design and building performance simulation will then make that link between the two topics, and that will introduce us into the themes of the special issue, building performance simulation and the user. So that will describe the papers we've got, then we'll go through summary and conclusions. So, context. The wider context is sustainable development of buildings and the built environment. I'm sure no introduction is needed to the audience on that wider context, which includes the challenges of climate change and resource usage. The industry context, it's a complex industry. There are many disparate stakeholders, and of course, the built environment is driven by many factors: economic, commerce, legislation in different places, creativity of designers and engineers, carbon, accounting, so on and so forth. And in our context, we see this potential for increased use of BPS in the future. And the point is, it's for a variety of reasons and purposes that we won't be able to necessarily predict at the moment. Right, next slide. No, got the same problem.
You might want to wait to appear on the screen.
Okay, that's changed. It's possibly just a delay on the line. Right. So, given that complexity of that environment I've just referred to, we think that the simulation community in general has paid insufficient attention to the needs of the users of building performance simulation. We did write a small article on this in the IBPSA newsletter a couple of years ago. That quote is from there. In general, we think there's been relatively little work done on what people use BPS for and how they prefer to interact with it. This means that the tools don't always respond or support the way professionals interact with their work. And that would lead to a potentially poor uptake of BPS, which several researchers have commented on as being the actual fact of the matter. So Henson and Lamberts have said that in their introduction to building performance simulation. Yes, it's taking a long time to change slides. So a user-centered approach could potentially make use of techniques and methods developed in the digital and product design industries to produce software and interfaces to better support the needs of users. So we're all familiar with mobile phones, sophisticated computer interfaces. These all make use of user-centered design techniques. User-centered approach would also see building performance simulation not as a single, for instance, piece of software or a single user indeed. It would see BPS as part of a wider system or systems, which ultimately that system is concerned with designing buildings and energy systems that affect our environment in less harmful or more positive ways.
The idea of adopting this approach is that it brings us some challenges, and as part of these challenges is how do you work in collaboration with various perspectives and disciplines, from which we include not only building engineering and building design, but also human-computer interaction and interaction design, computer systems development. As the role of the user of BPS has been insufficiently explored to date, there is a need for conceptual, theoretical, and empirical work on the topic. And to date, we have seen a little bit of empirical work on the topic, but very, very little work on the conceptual and theoretical front. Next slide. So what we did is we decided to do this special issue basically to encourage the community to take a more user-centric approach to BPS and explore a wider range of perspectives in relation to that. And we have then 3 different themes, which are the goals and tasks of the users, that is what BPS is used for and why, the different levels of knowledge needed to use BPS, and the interaction of users with BPS. And we will then present the contributions that are in each of these 3 different topics and comment a little bit about them so it triggers your curiosity to read the whole articles. Next slide.
So again, on the background, for those who aren't familiar with this area, user-centered design started with human-computer interaction, which in general examined relationships between humans and computer systems they use to perform various tasks. Over time, this changed, or developed rather, and became interaction design, which is a wider, one could call it a wider view. So the focus here was on the interaction between people and computers and computer systems. And the intention was specifically designing interactive products to support the way people communicate and interact in their everyday and working lives, is one definition of it. So rather than the purely scientific, I guess you could say, human-computer interaction, started thinking about the people and the products. We're now in user experience design era, if you like, UX. So the user experience design is considering the whole experience of the user from when they start needing some sort of product, or they have some sort of problem, they have some sort of goal. It starts at that point, then developing a product, perhaps how the person gets hold of that product, how the product is supported, and so on. So very wide through the whole area. So a user-centered approach will require the HCI designer to let users and their goals drive product development. So you might start to notice a difference between what is often current practice in BPS, which is generally, if one can be general about it, to produce some software and say this is what the software does. Whereas starting with the user as the starting point. Right, a little delay. So products designed with the user in mind, as opposed to purely engineered systems that deliver specific engineering functions. There's a lot of literature on user-centered design, including the research methods, principles, and so here's an example of this is the most general example of the principle for the design and evaluation process, typically adopted in this area. Is this focus on the users and their tasks, study them. In other words, the research is done into those areas prior to anything else. When prototypes, proposed scenarios, simulations, and so on can be made, then the reactions of users is measured. So they're tested, and then following that, there are as many iterations as needed of designing, testing, measuring, redesigning, testing, measuring. The key principle that's always been there in HCI and UX and interaction design is know the user. It's a key principle. Changing slide. Current research, this is the last slide on this introduction. So current research in those areas, just to summarize, types of users and what they need and want, the interaction with computers and systems, interface design, information visualization. There are others, that's the main categories. The cartoon on the right summarizes quite nicely how the developer is interested in 2 things: the person, the user, and the system that they're looking at. And ideally, there'll be a rather seamless link across those 2 different systems, if you can call them that. Next slide.
So then the practice of designing interactive digital products, environments, systems and service, which we call interaction design, which is the field of interaction design, is what we are trying to bring to the idea of BPS user-centered development. So thinking as building simulation as part of a wider system that includes the users, also buildings and systems designed using the tool, the simulation tools. So that these BPS processes and outputs are actually products useful to help people complete their tasks and achieve their goals. And for that to happen, we need knowledge transfer from interaction design, human-computer interaction, and user experience to building simulation. So it widens the use of the simulation tools in designing low-energy buildings and low-carbon buildings. Next slide. And we see opportunities for that to happen by starting with integrating these tools within CAD environments and BIM environments, but not stopping only there, but pushing things further and actually developing perhaps the whole system in a more integrated way and more tailored to the different users. And we start then listing different users. What users we have for that? We have architects, we have building design, well, we have civil engineers, structural engineers, consultants in general, mechanical engineers, builders, building owners, clients, and investors. So we're not talking about occupancy modeling here. It's not user-centered design with a sense of occupancy modeling, but it's the user of the software and actually what this person needs to do their tasks, their everyday tasks, to achieve their everyday goals and to fit within their working process. Next slide. We then put together the idea of the special issue, for which we had loads of submissions, and we ended up with 6 great contributions with 3 different topics. The first of them is the goals and the tasks of BPS users, in which we then describe what BPS is used for and why. And then we have 2 contributions there. We have then the second part of the special issue, which refers to the different levels of knowledge needed to use simulation, and basically a bit of different ways about how to teach simulation are explored. And finally, the way, well, interaction of users with building simulation, and then again, 2 different ways of interacting with the tools. Next slide.
So starting with goals and tasks of users, first paper is from Roya Razi. Excuse the pronunciation, I might have got that wrong, and colleagues. The reason some of the papers often cover more than one area, they can cover several areas, but they're particularly strong in one area. In this area, there's a very specific user, that's the building designer, and there's a very specific task, achieving performance targets in early stages. So this is probably a task shared by, probably shared by many designers. The approach also that they've recognized, the authors of the study, is that design has an iterative nature, and so this is embodied into their method. Also, they've recognized that building designers tend, on the whole, to have a rather limited knowledge in the domain of building physics. So again, the method is structured in such a way to take those into account. The approach itself, which we won't be describing in any detail here, we'll leave that for the paper and the webinar that they will do in the coming weeks. But in this case, there's a combination of methods: simplified energy method, a inverse linear modeling, and computer-based sampling methods. And what this gives, in very general terms, if the input is a performance target, then the output is a range of allowable building parameters that will allow that performance target to be achieved. I'm sure they'll correct me if I've made a sort of wrong interpretation of that. We note that could be further applications to this approach. It could easily go into a parametric design environment, it would seem. One point, a general point on their contribution, user-orientated BPS, building performance simulation, might well actually require a combination of methods to make the BPS processes and results more available to users, as it has in this case, it would seem.
We then have another contribution into the to the theme of goals and tasks, which is from Lunen and colleagues, which is the opportunities and pitfalls of using building performance simulation in explorative research and development contexts. In this case, the user is a different type of user, is basically a researcher and product developer, and who has actually ill-defined tasks, and tasks that actually can change all the time, because every time it will be a different product, which will require different methods and different algorithms potentially to look at. The point of this work is to show that in this case, for this particular user, research and development actually requires a virtual laboratory. So simulation acts as a virtual laboratory before going to real experiments to save time and resources. They then show 3 case studies in their paper and discuss these 3 case studies in terms of the problem formulation versus what currently BPS tools can offer. And note that there is a big lack of component models and algorithms to cope with the new development or with product development in general. Putting forward the case for using building performance simulation alongside emerging digital production technologies in the construction industry. So we have there quite a different use as an example, together with a building designer. Next slide. And we thought that this was interesting to bring up the discussion in relation to actually what are the different uses for building performance simulation, because you can use it for building analysis and measurement, you can use for design decision making, product development, to check if you're meeting regulations and standards, for policy making purposes, decisions on investment, there are work on that area, and then any other specific uses one can imagine that are possible here. There is also an aspect of it which is related to the people using simulation. So what are the goals and tasks of these people, and how are these people inserted into a wider context? I mean, an organizational context, for example, what are the ambitions of the organization in terms of using simulation, and how these people fit into these ambitions? Next slide. And finally, we have also to have a look at the wider context of the use of simulation tools in terms of the skills of people using simulation, how knowledgeable they are of the tools and physics itself, and what are the availability of people in the companies to use simulation? How does the office, or what is the structure of the practice? Is this a small office, a large office? How is the, where does the software fits into that structure, which is somehow connected to the fee structure, or how much will people be able to charge? Does that justify the investment? What are the responsibilities and indemnity? What do you use simulation for? Are you using it to debate decisions with consultants, or are you using it to do it, well, to actually inside your practice without needing to outsource anybody else, which again is connected to liabilities, and procurement and contract routes. So how much all that is important in defining, or how much that affects the use of the tools in the end. Next slide. We then think that time is overdue for the community to place this user at the center of further development, because if you think about the context, the different uses, and also where these people are working, what types of problems do these people need to address, and what is the context for these problems, and how do they interact with these problems when trying to solve them? Because ultimately, you can only give people or the users full control over how, why, and when to use the tools if you effectively support their working process, if you have a tool that can support their working process. Next slide. This then brings us to the next topic of the special issue, which is related to the knowledge needed to use building performance simulation, for which we have then 2 contributions. One, which Sarah Al-Sadani did it with myself, called Performer, Consumer, or Expert, a critical review of building performance simulation training paradigms for building design decision making. in which we discuss who is using simulations in the design context and who might be using it, and sort of present from a literature review the theoretical foundations for teaching simulation for design decision making. And that teaching is sort of connected to 3 levels of proficiency in domain knowledge to operate simulation in 3 different contexts, which you can see from the diagram on the side. Next slide. We have basically 3 different kinds of users there. What we call the expert, who is the person exploring simulation in its full potential, the one that is sort of can solve any problem and can fit into any context, and is basically a person that is going to be generating evidence for design decision making. And then 2 other types of users, which are people running simulation themselves within the design environment, the performer being the designer himself or herself, running the tools and making decisions as running it, and the consumer being actually a designer that is consuming simulation from a third party, a consultant or somebody else engaged in the design process and acting upon results. And this would bring actually 3 different paradigms of teaching simulation. And if you have the 3 different users in this context, you have to tailor the knowledge to this user. So what knowledge do you need to give to these 3 different types of users, and how can you effectively convey that knowledge? Next slide. We then have another contribution in relation to knowledge needed to use building performance simulation from Ian Bosley-Morrison, which is called Learning the Fundamentals of Building Performance Simulation through an Experiential Teaching Approach, in which the whole it's a detailed description of an example of teaching the expert and how and what does it involve, with in-depth discussions of the different levels or of how much knowledge needs to be given to this expert. So an in-depth knowledge of building physics, modeling literacy, and tools applicability, which then is taught in these cycles in which you have a topic which is explored in terms of studying the theory behind it and then doing simulation exercises, running an autopsy on the exercises, reflecting and connecting to the next topic. And the whole point of having such a detailed and like in-depth approach is to make a claim that actually teaching simulation is a topic that deserves as much attention as the development and validation of the models and simulation tools themselves. Next slide. And the whole point here is because actually the tools are very complex and they require proficiency for reliable operation. And if you do not provide, or if you do not have people operating these tools with this deep level of knowledge and proficiency, you have a big you are in an uncertain territory, because actually the main source of uncertainty in the whole simulation process is the user. So the whole focus is on training people to do virtual experiments, to assess cause and effect relationships, and to apply this into any context of simulation use with an in-depth knowledge of building physics. And experimenting is central to this, which is something that's quite interesting to see from this contribution and also the other ones. And which in the end makes us think, is this the level of competence, also the basic level needed for understanding and managing the complexities related to simulation? Next slide.
So summarizing on that little section on knowledge, clearly the type of user is a factor here. There's a question about the levels of knowledge of the user in specific domains and in the context in which they are working. Question marks about that. Knowledge, one could think of it in terms of domain knowledge, for example, building physics, building services and energy systems, perhaps the influence of occupants, or broader topics like passive design principles. These are domain knowledge. And then BPS related knowledge, which has just been mentioned on the previous paper, modeling, analytical methods, generation and interpretation of data, for example. And these are all needed to actually use BPS in design, and actually using BPS in design needs knowledge of in its own right. For example, about meeting targets, what targets are, or comparing design options, integrating systems, minimizing heat losses. Anyway, for current BPS system, in inverted commas, we know there are different ones, but in general, a wide range of knowledge from the user is required to operate the tool. And this brings up the question of knowledge transfer between experts and non-experts. If what we're looking at is this range of users, is it possible to transfer knowledge? Well, there are suggested methods and actual methods for doing this. And so as a selection, there are 4 here. There are others. Performance assessment methods proposed by Clark, which are about ensuring consistency and comparability in performance and quality of model or quality of analysis type assessments. So there'd be some sort of standard between different groups doing simulation or different professionals doing simulation. In Energy Plus Open Studio, there are the measures, energy conservation measures, which can be automatically applied to models. So these are transferring modeling knowledge or indeed energy conservation knowledge. One that we proposed was design patterns based on patterns of Christopher Alexander, which are wider still in that they look at the whole context of design. In Alexander's case, it was designing buildings. In our case, it's doing simulation in low energy design. So combining model settings, analytical methods, the outputs, the design advice that come to the user, and links into further patterns. So a rather sort of broad approach which would guide the user through making a low energy building. And more recently, visual programming is a topic where one can see the components of visual programming as being the components of environmental analysis and output. So there's a different sort of knowledge transfer going on there, or a different learning process going on there as well. So the key point, we think, one of the key points is interaction with knowledge. It's a broad concept, I know, but the interaction with knowledge is a key thing to do with building performance simulation.
Which then leads us to the last topic of the special issue, which is the interaction of users with building performance simulation, in which we have again 2 contributions. The first one provided by Elise Mendes and Nathan Mendes, an instructional design for building energy simulation e-learning, an interdisciplinary approach, in which basically they set up an e-learning tool within a constructivist approach to foster learning through experimentation, basically letting the user experiment and go within the tool and navigate in a non-linear way, in which they have then a contextual set of problems that accommodate different levels of knowledge. And the whole point here is to have problem solving contextualized, so it stimulates people to learn and also to develop a more complex thinking. Next slide. So this is a very interesting tool because it's like an online cooperative problem-based learning environment in which you have like context-based simulation problems set up by a tutor in a controlled way. And then the students are free to start experimenting with it, and they have a specific set of building physics concepts to learn, as well as modeling methods to learn. And they develop like the models, and they experiment with results and assessment, and they all get together in this instructor-directed peer discussion with a range of other users when they debate their findings, their procedures, and their methods. And you have then a case or an example of a full learning environment which could not only be applicable to their constructivist approach, but also could be transferred to potentially teaching the experts, teaching the performers and the consumers, which were explored in previous contributions. Next slide.
The second paper in this section on interaction, and the final of the 6, from Jones and Reinhardt, effects of real-time simulation feedback on design for visual comfort. So the idea here is that if real-time feedback is given, then the user's interaction with the software, with the simulation software, is greatly enhanced. Because there's no disruption in a creative flow, the task will require less effort and can be done without so much thinking about it in a sort of semi-automated mode. So a key point here is that designers need high levels of interactivity with the tool to make decisions during active design. Another aspect to this paper is that they measure human performance in comparison, using their new proposal in comparison with existing tools. This is a great thing to do and is part of human-computer interaction development as understood in the wider world. It's all too rare in BPS, one suspects. But anyway, this paper does that, and it therefore is an inspirational model really for anyone who's doing similar work on interaction and interface development. So, wrapping up on the interaction of users with BPS, there's an emphasis in all the papers to a certain degree on experimentation. And experimentation can be part of a learning process, whether it's learning about BPS, whether it's learning about building physics, or experimentation is part of solving a building design problem. In other words, experimenting to find a solution to some aspect of the building design. Systems and interface is a key issue with interaction, and it goes without saying, hopefully, that the systems and interface should support the users in their tasks. Hence, one needs to know who the users are and what their tasks are. In fact, an ideal HCI system has been defined as one where users carry out their tasks without even noticing the computer system. So in the last paper we just looked at, that's a principle that's underlying that work. There are issues to do with systems interface, for example, simplicity of interface versus a complexity of the interface. There are advantages and disadvantages to both of those. And the question is, what is appropriate for the particular user and particular task? How much control does the user have? How much is the user given or able to take? It's another key issue. How much of that interface is automated? How much of the process is automated? Some of those were mentioned earlier with, for example, energy plus measures. A certain amount of automation is possible. How does the user intervene in that automation? So when interfaces are being developed, there are key questions that should start at the beginning before development about how much control is going to be given, whether maybe intelligent agents are going to be used to run the interface or help to run the interface in some way.
Which then brings us to our summary and conclusions of the special issue, which we basically bring some topics to be further developed, in the sense that to think what users need from simulation and how they interact with their problems in attempting to solve them as a fundamental thing to think about when you are improving or developing your tool. And then how much domain knowledge is required to use simulation and what that knowledge should be when we are teaching simulation, or even when we are attempting to learn it. And how to make better use of the simulations in the design context. And we see examples of that throughout the contributions, and they can be quite different. But the focus of the whole, I think the focus of all the contributions is on experimentation, and then the central role of user interaction, either with the central role of users interacting with the tool, either when learning about it or when using it for problem solving. Next slide.
So future work, some pointers which come out of the special issue. User-centered design is multidisciplinary stroke interdisciplinary. not only do the stakeholders, who might be the building designers, the architects, the engineers, the building owners, the finances and so on, but actually when one is developing the BPS system, that's multidisciplinary as well. One would expect software engineers to be involved, interaction design, user experience designers, researchers, people doing marketing, and of course the range of stakeholders. So that goes with the territory of user-centered design, that sort of wide spread of expertise being input. Also, user-centered design is an iterative process, which we mentioned at the beginning and re-emphasize now. Understanding the context of the use and the users, leading to a specification of user requirements, leading to proposed design solutions, leading to an evaluation made against those requirements. And as the diagram indicates, following the results from the evaluation, this iterative process can be entered at any stage. For example, re-understanding the context or redefining the context of use, re-understanding the user or finding out more about the user, re-specifying the requirements through talking to users. So it's a developing scenario, proposing new design solutions or modified design solutions and evaluating again. And finally, borrowing research methods used from other disciplines is very common in this field. So both qualitative and quantitative research methods are typically both used.
Which then brings to the final message, which is building simulation should be seen as a product also, in which there is interaction with knowledge and, well, a complex product in which interaction with knowledge is essential. We thank you very much for being with us, and we open it to questions now.
Yeah, thank you, Clarice. Thanks, Simon. Do we have any questions from the audience? So far, I have not received any question using the pane. No written question I have received. But anyone wants to ask, probably either I can unmute or you can send me a question on the question pane and I'll ask that question. Anyone from the audience wish to ask a question? Not really. Meantime, probably I have one sort of clarification or some, if one of you, Simon or Clarice, if one of you can elaborate a little bit more on the parallel which you're trying to draw with the Christopher Alexander's work on a design pattern where buildings were in the focus. And you said something about design pattern in building performance simulation. Can you just elaborate a little bit on that topic?
Yes. Yes, certainly. That work was looking at. A lot of people will be familiar with Christopher Alexander's design patterns, which would look at the built environment from a very large scale, that of a city, perhaps, or a town, right down to a small scale of how the components in buildings, and would provide a network, if you like, of good practice that has been understood over the years, according to Alexander, of how things work well, how quality is built into the built environment, and so it's really a look at historical sort of successes in built environments, and then putting them into little design patterns that would fit together, and so you could draw out the right pattern or the right recipe, if you like, at the right time to help guide design for good built environments. And it seems like a good sort of analogy with building performance simulation linked to building design, in that some things in building performance simulation one does again and again. There's some things that are procedural and some things need a new approach. For example, passive strategies for different parts of the world tend to be known already. Therefore, they can form patterns. Now, if those can be, or more in a more sort of specific example, for example, with climate change, is a building going to overheat in 30 years' time with climate change? These sorts of things can be modelled, and the weather files, we have them. And one can imagine packages put together to test those questions that people have about buildings, commonly asked questions, or maybe not so commonly asked questions. But if we would ask those questions more consistently and be able to get answers for them more consistently, this might help to make good environmental design. So there's the analogy with Christopher Alexander's good building design. Don't know if that, you want to add anything to that, Clarice?
No, I think it's exactly that.
Rajan, does that answer your?
Yes, that's. I mean, I got a little bit more insight into what you were trying to say. We have two questions. One is from Alberto. Alberto, would you mind asking question? I have unmuted you.
My question is related to the that interface in the relation with the users and the owners and experts. Should we think about maybe simpler tools that can provide some insights on the building performance that will be easier to get that interaction that you guys mentioned before, instead of using Energy Plus, for instance, or using Energy Plus, but in a different way? Let's say provide information and somehow, I'm thinking maybe, I don't know if you're familiar with the LT method, something like that.
Yep.
Yes, I think an example for that would be our first contribution, in which we have like this idea of really understanding designers as not really proficient in building physics, and therefore trying to provide an interface that is simplified, but at the same time an engine behind it that can give the data that this user wants. And that's why you have their BPS inputs as performance targets. So it's basically the user needs to meet a certain target from whatever regulation, or to comply with whatever set of standards or regulations. And then the tool actually helps to provide a range of building parameters that can help this user to get there. And it's not really leading it to a classic simulation or dynamic thermal simulation, but it's actually using a combination of methods between the user and the engine that enable that to happen. I think this is a way that, well, this is one of the approaches, and that will be one of the next webinars. But yes, Simon, do you want to add something to that?
Yeah, I was just going to add the idea of the constrained interface, which is a technique that's known, where a constrained interface is an interface that's custom made, which will have a more complex engine running underneath it, but is tailored to a specific user. I would also emphasize it's a matter of understanding what that user wants, the one who you mentioned in your question, what is useful to them. If one knows that, then one can, assuming that building simulation is going to be a useful part of that, the answer to their questions, then one can make a constrained interface. Does that answer the question?
I think so. We have another question from Minu. Minu, would you like to ask a question? We have a question from Minu Agrawal. Okay, let me ask on her behalf. Her question is: are there any topics that you were really hoping to have in this special issue, but has remained outstanding? She's just curious about it.
Yeah,
that's an interesting question.
Good question. Our starting point was to actually find out what would come in. We thought it would be interesting to see what came in. Those areas that we mentioned are we already had a good idea about goals and tasks, and we knew there's something about knowledge, and maybe we didn't think so much about the interaction. But no, I think pretty much everything. What we didn't have was technical systems design type contributions. But by that I mean we've had the Mendes and Mendes wide system. Actually, I'm sort of wrong about that. We had the lighting analysis system as well. No, I'm wrong about that. I have to refer to my mind sort of a year ago when we started this to what we were expecting. Clarice, can you remember a year ago what?
I don't think we were quite open-minded as to what was coming, but I think we got a little bit surprised by the volume of contributions on the teaching front, which was quite interesting because it was a bit unexpected that would be seen as a case, and how well that could be viewed from the perspective of the user. So we thought that was a very interesting thing that came, because we were expecting perhaps a bit more contributions more on the sense of different types of use and perhaps some experiments with different interfaces and things like that. But then it did surprise that we got contributions on the teaching front with that mindset of having the user as like a primary concern or the focus of it.
Okay, I think that satisfies the menu, I'm sure. We have one more question from Thiago Goes. Thiago, can I unmute you? Would you like to ask a question? Is that Thiago?
Wait, hi. Sorry, I would like to ask a question. As an architect, I still find difficult time integrating the simulation process in an early design process in architectural design. My question is, as you guys said, sometimes the conceptual framework, the questions as designers that we want to ask are still difficult to be asked in the framework that we work in building simulation. How do you see this going forward? Which tools do you see that could integrate different frameworks to foster insight and a more exploratory way of thinking within building simulations tools?
Can I take that?
Yeah.
Yes, it's a good question, because I think the way I interpret your question is touching between almost two different languages. In building design, there's activities going on, and then the tool can often interrupt because it's speaking in a different language. It has a different agenda, the tool, from the actual design process. So I think it's about interface more than anything else. I won't mention specific tools. I think they're yet to be developed, but they are being developed. So I think in terms of the interface, I did refer to the design patterns, for example. I don't particularly push that one, but that is specifically, the idea there is specifically to bridge between design and the sorts of questions one is asking or could be asking in design, even though a lot of design is not to do with asking questions about environmental performance at all. It's about totally different things. But if the place of environmental design can be allowed to be part of the design process, then that would be a good achievement, I think. And so I would see the interface and something like design patterns or some similar type of system that is specifically there to try and bridge that communications gap. Clarice, do you have any points?
are potentially working on a way in which you can set up your targets and then having the tool giving you some kind of ideas of which direction to go in terms of which design parameters you could change to improve the design. So a bit similar to this contribution that we have in the special issue, in which you set up your targets and then you are provided with ranges of parameters which you can work with in order to achieve that. I think that can be a good thing to look at the early design stages. The thing is, in the early design stages, you have to integrate information. You can't have a lot of different data to look at, because you need to proceed in a very holistic way, and you cannot control lots of different parameters or outputs at the same time. So something that can give you ranges of parameters, design parameters to explore, potentially is more powerful than actually having you to do a trial and then check results and then doing another trial and check results. That would be like a different solution to the one of the patterns, but you can also have these patterns as almost like an automated thing within your tools, which either via you or an intelligent system identify what is more appropriate in that case and then automatically run it just to check or give you an indication of how you're doing. Not sure if that answers your question, but.
Let me unmute him. Does it answer the question, Tago?
Yeah,
good?
Pretty much. We have been working with a lot of parametric and optimization to try to have this sort of insight, but as you said, sometimes the problem is they're more holistic issue. So sometimes the parameters, they go in different ways. So pretty hard to combine this sort of thinking in a really pragmatic, parametric or in parameters. It starts putting you in a sort of box, I think.
Yeah, because the problem that you have is that you change one parameter and it affects other performance issues. So you get into a crazy mode because you change one thing and it affects different outputs, and then the whole thing can get out of control. So I understand exactly why you're asking the question. And maybe thinking the other way around, like having parameter ranges to operate within, would enable you to better control the fact that you are actually responding to different performance metrics without, by changing something into one, completely damaging the other.
Great. Thanks. We don't have any further questions from the audience. I thank Clarice and Simon for setting up a tone for next 6 sessions. I'm sure that each of the next sessions would be very, very engaging and very fruitful. I must also announce that registration for the link simulation and conference in Rome is now open. I encourage people to register and attend conference, and at the same time, I also encourage people to join IBPSA as a supporting member. All supporting members received a complimentary subscription of Journal of Building Performance Simulation, which is endorsed by IBPSA. So all those, what we're discussing in next 6 sessions, which are based on those papers, would be available to IBPSA supporting members on complimentary basis. So I really encourage people to become a supporting member of IBPSA. With that note, I close this session. Thank you, Clarice. Thanks, Simon. Thanks for your support.
Thank you.
Thank you.